In this tutorial, we're going to be looking at how to create geometries and generating paths that follow the edges of the geometries using the AutoPath function. We will also look at the importance of speed and precision of the robot arm, and learn how to change these parameters for a given motion path. As you can see, we have our path that we have made in the previous tutorial. Let's just press play here to refresh your memory and watch what the robot does. Now, for a simple path like this, the robot does not necessarily have to reach the point that we specified exactly. However, when we start to look at more complex paths, it becomes more important to make sure that the robot can reach a specified position in time and at the exact spot that is given. To demonstrate this, we're going to create a path that follows the edges of a geometry. Now, a geometry is just a CAD model that the robot can interact with. It can take the form of quite literally any object possible, and usually it can be made in any given CAD software, like SolidWorks or AutoCAD. However, RobotStudio also allows you to make your own CAD models, and we are going to use the inbuilt CAD modeling system to make our own custom model. To do this, we go to the Modeling tab and we click on Solid. For now, we're going to create a box platform. You can specify the corner point of the platform based on the origin, and also specify the length, width, and height of the platform. You can also see a preview of the platform in the workspace. This allows you to adjust the initial position values and make sure the platform is in the correct place. Click Create, and the platform is now in the workspace. We're going to add another smaller box on top of the platform. Again, we click on Solid and then Box. We can snap the corner point to a point on the edge of the platform by using the Snap Object selection. This shows up corner, mid, and center points on the object face. We're going to snap to this corner point here. Again, you specify the length and height of the box here. Click Create, and now the box is made on top of the platform. Finally, we're going to add a small cylinder to the center of the box. Once again, click on Solid, then Cylinder. To snap to the center of the box, click on Snap Center. Specify the radius of the cylinder and height, and click Create. Now you've created your CAD model that you'll be using to create some advanced custom paths. Next, we're going to create a work object for the model that we have created. We will store all of our targets for the path in this work object. Using Snap Object, we will position the frame of the work object at the corner of the platform here. We will call this work object AutoPath Move Around. Now we're going to create an AutoPath. An AutoPath is a path made from the edges and curves of a geometry. We are going to use the AutoPath function to create paths that follow the edges of the small box and the cylinder. To create an AutoPath, you click on Path, then AutoPath. The first AutoPath we will create will be the small box. Now, in the AutoPath window on the left, you can see that there are a few options that we can choose in how to create the AutoPath. You can see that there are three different types of AutoPaths. These are linear, circular, and constant. The default option selected is linear. To create the path, you can simply hover over the edges you would like the targets to be created at. As you can see, the edge is highlighted red, with an arrow facing the direction of movement. When you click on the edge, you can see that the red edge is now solidified, and there are now two yellow circles. These circles indicate the targets that have been created, and these circles have an orientation. So, the red arrow is the x-axis, and the blue arrow is the z-axis. By clicking on the adjacent edge, you can see that there is now another solidified red edge. Continue to do this until all four edges have been selected. This is the first path that we will create. Click Create and you can see that the path has been created. However, the path does not reach the middle targets exactly. Instead, it curves around the target. This inaccuracy of the path is determined by a variable called zone, indicated by a Z. This can be seen when you right-click on one of the instructions, go to Modify Instruction, and then Zone. The zone is set to Z100, which means that the target has a 100mm radius zone around it, where if the path enters that zone, the path will curve towards the next intended target. By changing this zone to fine, the path will now have a trace following the edge of the box. Again, the orientation of the tool and robot must be checked to see if the robot can reach the intended targets. Use View Tool at Target and View Robot at Target to check this, and if the orientation needs to be changed, use Modify Target to do so. We're going to name this path AutoPath Linear. Now we're going to create another AutoPath around the cylinder. Since the cylinder is circular in nature, we will use the circular option to create our path. So click on Circular, then click on the top edge of the cylinder. Notice how there are only 4 targets created. This is because the circular option creates circular move instructions that approximate the edge as circular segments, rather than the line segments that the linear option created. To illustrate this, click on Linear. You can now see that there are many targets created, and you can also see that between each target, the segment is a straight line. You can see the same result if you click on the Constant option. This keeps a constant distance between each target by dividing the edge up into line segments, similar to the linear option. Ideally, we want to keep the number of targets to a minimum if we can, since generating more targets creates a heavier workload for the robot itself. Click on Circular, then press Create. Once again, check to see if the robot and tool can reach the targets created, and change if necessary. We're going to name this path AutoPath Circular. Once again, make sure you remove any potential configuration errors by clicking on Auto Configuration, then All Move Instructions. We can check the motion of the path without synchronizing to the controller by right-clicking on any one of the paths and clicking on Move Along Path. Let's click on AutoPath Circular. You can change the speed of each instruction by right-clicking on the instruction, going to Modify Instruction, then Speed. The default is set to V1000, which means the robot moves at a speed of 1000 mm per second. Let's change this to V100, so 100 mm per second. Do this for all of the other instructions in the path. Now let's see what this does to the path. As you can see, the speed of the robot is clearly slowed down. The speed of the robot becomes more important when you're handling delicate objects with other end effectors like grippers, since a high speed between targets would result in those objects being displaced and potentially damaged. Now, synchronize the paths created to the controller, again making sure all of the boxes are ticked. Now you can press play. Notice how nothing is happening. This is because we synchronized all 3 paths to the station, but we did not link the paths together, i.e. the linear and circular AutoPaths have not been called in the first path. To fix this, we simply right-click on the first path, go to Insert Procedure Call, then click on AutoPath Linear. Repeat this for the other AutoPath. To ensure the tool travels to the box region from the first path, we add a move instruction between the end of the first path and the beginning of the second path. Now, the beginning of the second path is set at the target 50, so we simply drag target 50 to the first path. Since the orientation of the target is changing between the 2 targets, we cannot use a move out instruction, since this keeps the orientation the same. So instead, we use a move J, which will ensure that the tool travels to the target with the correct orientation. To change this, right-click on the instruction, click on Edit Instruction, then at the top, change the motion type to Joint. Now, synchronize to the controller again and press play. The robot moves through all of the given paths as shown. This concludes the introduction to RobotStudio. In the upcoming intermediate tutorials, we will introduce smart components, station logic, and begin to look at and add wrapper code to the program.